Welcome to Maths for Each channel. Another past question on mathematical induction proof. Let's look at the question. Prove by mathematical induction that for n is an element of positive integer, a series 1 plus 2 times half plus 3 times half to the power of 2 plus 4 times half to the power of 3 and so on, n times half to the power of n minus 1 equal 4 minus n plus 2 divided by 2 to the power of n minus 1. So we need to prove that the sum of the series on the left hand side equal 4 minus n plus 2 divided by 2 to the power of n minus 1 by induction method. I just rewrote that question. The left hand side the series, the right hand side the actual the sum of that series, and the n is the positive integer. Prove by induction. Prove by induction. Step 1, n equal 1. Left hand side is only one component or one term of that series, which is 1. So left hand side is 1. The right hand side is n equal 1. If you could substitute that value, n equal 1, to that term, the sum given, 4 minus n plus 2 over 2 to the power n minus 1. n is 1. So 4 minus 1 plus 2 divided by 2 to the power of 1 minus 1. 1 minus 1 is 0, 2 to the power 0 is 1. The numerator 1 plus 2 is 3. 3 divided by 1. So 4 minus 3 equal 1. The right hand side is equal 1, left hand side equal 1. So the step 1 satisfied. And step 2, assume that the equation is true for n equal k. So we assume that the up to the n terms of series, sum of term series equal to the function 4 minus k plus 2, or they're the given sum. Okay, let's write it. Left hand side, the series, which is 1 plus 2 times half plus 3 times half squared, and so on, up to k. K times half to the k minus 1. The right hand side, the actual sum given, 4 minus n plus 2. So 4 minus k plus 2 over 2 to the power k minus 1 is n equal k. So that is up to k equal as assumed. So what we're going to do now, we need to prove that this is true for k plus 1, n equal k plus 1. In order to do that, the term after k term, or k plus 1 term, is k plus 1 times half to the power of k. So if we could add that function k plus 1 times half to the power of k to both sides of the equation. So because I assumed the equation, both sides of the assumed equation, which we took it when n equal k. Right, the left hand side is rewrite the equation, 1 plus 2 to the power half up to k times half to the power k minus 1. Now we are adding k plus 1 half to the k, that's the next term in that series. So k plus 1 half to the power k. If we do add that, and of course we have to add that the same amount or same function to the right hand side. So the right hand side, we assumed it before, 4 minus k plus 1 divided by 2 to the power k minus 1. And now we have to add k plus 1 times half to the power of k. Let's do a bit of simplification. Keep the 4 out. So inside, take minus out. So the first term will be if you look at it, k plus 2. Yes, there's a little error here. This is 2. This is 2. So k plus 2 divided by k to the power k minus, sorry, 2 to the power k minus 1. Minus, because of minus, plus divided by minus, k plus 1, 1 to the power of k is 1, and then 2 to the power of k to the denominator. Now, further simplification, 4 minus, here 2 to the power k minus 1 is 2 to the power k. So the LCM, 2 to the power of k. LCM 2 to the power of k. Here 2 to the power of k divided by 2 to the power of k minus 1, which is 2. So 2 times k plus 2 minus k plus 1. That will be 4 minus 2k plus 4 minus k minus 1. That is 2k minus 1k is 1k. And 4 minus 1 is 3. I purposely wrote that 3 as k plus 1 plus 2. K plus 1 plus 2, just to get the format. So 4 minus k plus 1 plus 2 divided by, again, k. I just wrote it as k plus 1 minus 1. So plus 1 minus 1 is equal. Therefore, k, I wrote it as k plus 1 minus 1. So now, if you look at that, we have proved the function, the sum of that series up to k plus 1 is 4 minus k plus 1 plus 2 divided by 2 to the power k plus 1 minus 2. So it is true, right-hand side is true for n equal k plus 1. Therefore, the series 1 to whatever up to n equal 4 minus n plus 1 over 2 to the power n minus 1. Thank you. Please subscribe to the channel and select auto notification. Thank you.